your real problem is that you don't understand your problem. That's what generally happens when you start breaking up monoliths into microservices. I am Geshan Manandhar, senior software engineer, call myself a tech solution provider, agile follower, and a conditional microservice believer, because microservices do not fit to every team and every organization. You really need to think of a lot of things before jumping into that microservices bandwagon. I originally come from Kathmandu, Nepal, the only country that has a non-rectangular flag. I think that's enough about me and Nepal already. Yeah, I used to work, I still work for one of the GFG companies, but I used to work for another one that's in the Middle East, and if you know your geography right, you know which company I'm talking about. I'll have more about that while I proceed with the talk. But right now, I am working at The Iconic, which is an e-commerce company in Sydney. Who of you know the brand Iconic, The Iconic? Okay, like more than half of the audience. So you already know that it's an e-commerce company. It sells shoes, clothes, and everything related to fashion. So that means all of, or most of my examples are going to be related to e-commerce and fashion e-commerce. Okay, for most of you, and for most of the people who were at The Iconic, I came from a future where there were no legacy monoliths. I generally call them 3 Ls: large, legacy, and lethal. So if you are working with very big applications, yeah, you will feel the pain. What pain? Who would like to answer? Who does not like working with legacy apps or monoliths? Almost everyone. So generally, it feels like you're trying to make that old van move, and then two people are like pushing it from the back, and it's still not moving, you know? So that's what generally happens when you work with big monoliths. There's a lot of friction there and a lot of things that need to be done so that it works well. So what to expect out of this talk? I would say nothing. Here, basically, I'm here to just express and share my story and experiences of how we moved from 2 monoliths to about 150 microservices, and how that transformation happened in a course of around 5 to 6 years, 4 to 5 years to be more precise. So let's see at what is microservices architecture. A visionary, Martin Fowler, says, like the highlights are, it's a single application as a suite of small services. It's built around business capabilities, and it is deployable independently. So look at the highlights. Those are pretty important stuff. Then another person who is pretty influential in this microservices space, Chris Richardson, says, like the highlights would be loosely coupled services that they can move independently. Okay, you can evolve the technology stack, and again, the focus is business capabilities. So whenever you think about microservices, you always have to think of that business slice. You cannot really break big monoliths haphazardly. You always have to think of the business slice and the business part or that business function that you want to address. I think that's what we need to take out of these definitions. So microservices at Namshi, that was my previous employer, and that's the journey that I'm going to describe. So the whole story started around, I think, 5 or around 6 years back. Back then, rather than just microservices, it was the era of SOA, service-oriented architecture. And what happened was we had 2 big monoliths. One at the back end, which was really big, not the back end, I would call it the back office, which had all the back office functions of an e-commerce. And then the other one, A, which was the front end, like the things that the people would see, that the end customers would see. So that's how the whole organization was running on just these 2 big applications, A, the front end, and B, the back office system. Then what we did was we started kind of trying to break it, and then we created another beast, I would say, which became a beast in like 1.5 years. That was C. So basically, we started extracting out things from this back office system, and then we started putting it into another, again, monolith, which was C. So doing it that way, we learned a lot of things. But along this course of line, we learned some good things as well. One thing that actually helped us a lot was migrating to a REST-based backend JSON API. So the backend was basically JSON in, JSON out, and HTTP-based. So this meant that 4 or 5 years back, we didn't even have a mobile application. But with the usage of these API, we could actually build mobile applications. Basically, the backend was always saying, give me JSON, I give you back JSON. So with that approach, the same backend could be used by a mobile app or another React app, or maybe if you wanted to develop a CLI app, even that could use that backend because it just give me JSON, I give you back JSON, we just follow the HTTP standard. This actually helped us trigger a transformation from where the server was not just spitting out HTML, JavaScript, and CSS, it was only talking, the backend was only saying JSON in, JSON out. Then the other thing that I remember that actually helped us a lot was having stateless authentication. The JWT-based, JavaScript Web Tokens-based authentication was a boon. It helped us do all the authentication without any states. That means there was no storing of sessions in the backend, no Redis server to manage all of your sessions and everything. Everything was thrown back to the front end. We just knew as soon as you get the cookie, can I validate it? Yes. Can I get, is it fine? Yes, then let the person go in. Rather than the cookie, it was just tokens, but as it was being communicated with cookies, it was a lot easier because browsers automatically give it back to you on each request, and you don't need to do another wiring like sending it from a HTTP header or things like that. So just putting that token into a cookie helped us a lot. A chunk of the backend is still in PHP, and all the other apps are in Node.js and JavaScript. So a lot of backend, almost all of the backend stuff right now is in Node.js. And even the front-end apps are, of course, JavaScript and generally built with React. I think this is the key point here. That in a course of around 4 to 5 years, we were able to break those 2 and then the later C, so around 3 of these big monoliths into something like 150 microservices. But a very key point to note here was the team was generally, the backend engineering team was generally around just 10 people. So I think this is a pretty good thing. One thing that you can take out of this is smaller teams move faster. Because I've seen bigger teams, they want to do big stuff, but they kind of get stuck, I don't know, into the bureaucracy, into the documentation and all those things, and don't really get the things done. I'm not trying to blame anyone, but that's what I've seen generally. So here's an example. Here are some of the microservices that we built. As I said, most of them will be from e-commerce. One of them is OMS, that means Order Management System. This is basically the screen that the customer service agents would just go and look at all the orders, look at the statuses, and then whenever the customer calls, they can tell them back saying, okay, this particular order is unshipped, blah, 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 or move the orders to other statuses. Something I remember working on from here is QC, which is the packing part of the things. So things are being picked from the warehouse, and it's being packed, and that was a completely different microservice that really helped us. Another thing that I worked that actually improved their productivity by, I think, around 25 to 30% was the studio application, the production application, which basically means the items or the SKUs have landed into our warehouse. We need to get them live so that the customers can buy it, and the journey between something landing into the warehouse and then it going live. That means all the imagery and everything concerned with it, like booking the models, taking the images, making sure they are refined and then retouched correctly, and then it goes online. So these kinds of things actually helped us a lot as Namshi to ship a lot faster. One other thing that I remember here is try to completely segregate your internal services that your employees use from the external customer-facing things. What do I mean by that? I mean that try to segregate all of the internal services into a completely different domain. That may be yourcompany.io, yeah, versus all the things that the customer use goes into yourcompany.com. So just looking at the domain, you can see, okay, this is an internal product. We can maybe sub-optimize it to a level because it's just used by our employees. But as soon as you see yourcompany.com, okay, this is a customer product. You have to be more careful here. You have to follow all the best practices. You have to put all of your effort here because every second counts here. But here you could relax a bit. I'm not saying you have to be careless, but at least you could relax a bit. If things need to move faster here, it's still fine. But if you break checkout here, your website just becomes a catalog, you know? So think of these things when you break monoliths into microservices. Yes, as I said, like moving into microservices really helped us ship faster. Just the talk like before me, the last lightning talk also mentioned the same thing. We were not really using a lot of pops-up, but having a lot of smaller moving parts talking to each other, that really, really helped us move faster. And as I said, we were just a team of 10 people. That also accelerated that growth and that speed. Yeah, one of the other things whenever you think about microservices is surely the infrastructure. You really, really have to be careful on how you design it, because if you have a lot of smaller parts here and there, and then you are not even Dockerizing it or have an orchestrator like Kubernetes, it's gonna be a big headache to manage. Probably you'll need like a 5-person ops team or like DevOps team, SRE team, whatever you wanna call them, to just manage it. So for us, because we had Dockerized all of our applications and then all of the new applications were directly going to Kubernetes, at one point we have only some applications not running in Kubernetes, and most of the applications running in Kubernetes. That was a bit difficult to manage as well. But once we had everything Dockerized and running in Kubernetes, it was a lot easier because Kubernetes takes a lot of this load out of you. And then you see, like, if our service A wants to talk to service B and service B talks to service B, you can manage these things a lot easier with something like Kubernetes. Wow, that was fast. I don't know why. Yep, I was here. Okay, so right now, 9 out of 10 applications at Namshi are written in Node.js. I'm trying to focus a bit more on JavaScript and not object-oriented technologies because you kind of leave the baggage behind. You don't really need to write applications that are heavy from the thought itself. So just think of it right now as they are small applications, write it in a way that it is performant rather than you're just trying to inject everything you know inside it. I'll come more into it. Another thing you have to figure is, till now I have talked a lot about the good things, but microservices surely are not free lunch. You really need to think of all the configurations that come with it. As I said, if you have service A that talks to service B and then service B talks to service C, you have to think of a lot of stuff. Like, for example, if all of them talk over the internet with HTTPS, there is a handshake involved with there is SSL handshake involved with every connection. So that can become a very big overhead if you're just jumping into it without really thinking of, okay, what's happening here. But let's say if these 3 services are inside Kubernetes and then they talk with the Kubernetes artifacts, probably it's a lot easier. So what I'm just trying to say is you really need to think and design the whole network stuff, the application stuff, to get the real value out of it. So how to get started with microservices? Yep, always start with an opportunity. Try to extract out a business feature or a function that's going to help the business. It's always about the business. For example, you cannot tell the customer service people, today don't use the system because we are doing an upgrade. They will start shouting at you, right? So always try to start with something that relates to the business. One important thing here is when you start, don't start with something that directly impacts the customer. Because as I said, if you segregate your internal stuff from your customer-facing stuff, this would be a lot easier. One example that comes to my mind here is you could do something that the customer places an order, it's in our system, but that particular order needs to go to your ERP system. That's generally what happens in many e-commerce ventures. So what you could write is you could write a very small service that just exports that order that's already in your OLTP database to your ERP. So that could be a small thing. The customer is never affected, but that can be extracted out into into your first microservice probably. That can help the business function, and which could be faster because you don't have an overhead of loading the whole application that does this export. Yep, another thing that you can start with is try to transform a pain point into a new service or a new microservice. So what do I mean by that? You can think this of, for example, let's say that the dev team generally complains about, okay, we are talking to these couriers to get our AWBs. AWBs are basically you get a number for that package by which you can track that package. So we are talking to A, B, and C courier, but they are very slow, yeah? And then the pain point could be because we are doing a synchronous call to them to get an AWB out of them, from them, that's why it's slow. So if you could extract that part, just that part out into a pub sub or a message queue which happens asynchronously, because the point there is as long as you can get an AWB correctly, that's fine. It doesn't need to be synchronous. It can wait for 2 minutes. No one's gonna die. It's not like you are trying to get a payment out of someone. So if you can think of those pain points and try to solve those and then come up with smaller microservices in those areas, it will really help the business. Yeah, the other thing is generally in software, it's very less about technical problems and always about people problems, communication problems. So along the same lines, try to solve a small issue and be collaborative about it, and then do it in a way that you can roll out working software. For example, the example I gave about doing an order export, that's a very small part of the business. So start small, always start small, so that you can show the business that you can actually you can roll out working software, and then the business has confidence in the development team. And then with that confidence, you can build stuff. For example, if you go to the business or to management and say, we want to completely revamp the front-end website, and it's gonna take 4 months, they are never gonna say yes, you know? But let's say if you go up to them and say, okay, we just want to rewrite the cart part, so only the part where you can add to cart, or for example, the wish list, which is not very critical, as well as which is comparatively easier to do and small, and it's just gonna take us 2 sprints or like 1 sprint. Then there is a very good chance that they are gonna say, okay, yes, let's do this experiment. Yes, and about this, whenever you start coding your microservices, always think out of the box. I just written a blog post about it, and the main things there were, don't take that overhead. You might not need MVC for a microservice. You might not need an ORM for a microservice. You might even discount using all the popular patterns, design patterns. Why? Because microservices are bound to be small. If you are gonna write a code, write an application, that's hardly gonna be 5,000 lines of code whenever it's done, or even in 6 months. Why do you need to take the baggage of MVC? Why do you need an ORM? You could just use raw SQL queries and get it done. It's more about performance at that point rather than trying to inject all of these things that you know because you are used to writing applications that are 100,000 lines of code or even millions of lines of code. There you need these things because these things need to be maintainable. But when you are talking about something that's going to be 5,000, 7,000 lines of code, why are you taking that overhead? By these 5,000, 7,000 lines of code, I mean your own code, not the libraries that you import. But why do you need to take that overhead? It's just going to make your application slower, because maintaining a 5,000 line code base is a lot more easier than maintaining a 1,000,000 line code base, you know? And plus, you don't have 200 people working on, like you have in a 1,000,000 line code base. This particular 5,000 liner could be owned by like 2 or 3 developers, and that's it. Other people who want to know about it just come there, look at 7 files, 10 files, and they know what's happening. They don't need to know, I don't know, PubSub or solid, or whatever patterns that you know of. Just think about these things. Feature flags and canary deployments always kept us on the safe side. One example that I remember here is once we had to completely replace the payment gateway. As you all know, payment gateway is the lifeblood of any e-commerce system. So we had to do this. And the first deployment we did was we just feature flagged it behind if your emails end in @yourcompany.com. So by that, we could already test the stuff on production, and no one was hurt. Even if we had a bug that would affect everyone, it was just our employees, and we could fix it pretty fast. The next week, we opened it up to only 2% of our customers. Still, there were some bugs, of course. Even if you test so much on staging, you're still going to have some bugs here and there when you do something like this. So with that, gradually, week after week, the percentage increased, and I think it took us around 2.5 months, 2 or 2.5 months when it actually went to 100% people. With that, the blast radius was very small in the beginning, and even if we had any issues, we could manage it very easily. So always think of this. Always think of whenever you break big monoliths into smaller microservices, always try to do a feature flag deployment and canary deployment where you can say, I just want to release this to, I don't know, 5% of our customer base, and gradually I would increase it depending upon how it works. The key takeaways. I think this is where you would learn new stuff again. The first, as I said, communication. Communication is very, very important everywhere, but here it's even more important because you're trying to change some of the business processes and how it works technically. Another very important thing is the management has to buy into the idea that they actually want to go into microservices. Some developers could be ranting years about, okay, this code base is big, I don't want to work in it, it's very difficult to ship new features, but nothing's going to happen unless it comes top to bottom. So the management actually has to buy into this idea and let you do things. Just because some developers want to rewrite X, it's not going to happen. You really need to convince all the people involved in that chain. Yep, replacing front ends could potentially take just months. But if you want to replace a back office system of a sizable business, it's surely going to take years. For us, it took like only some months, maybe 6, 7 months, where we could replace the customer-facing website. It wasn't that big. But when we started and come back to this back office system and start extracting stuff out of it, it really took us, I think, around 4 to 5 years when at the end we could say, okay, now this system is actually legacy and not used, and we could now use all these smaller things, all these smaller URLs, where you could use that old legacy system, plus building new things in that particular journey. One thing that you really need to think about when you do distributed systems is resilience. Because distributed systems are bound to fail. You have to think in a way that you don't stop failure, but how can the system recover early and or recover faster from failure? That's how you should be thinking, because this quote is inspired from a quote that says there are only 2 hard problems in computer science. One is naming things, and the other one is anyone? Cache invalidation, yep, the lifetime of cache. So similarly here, if you see what this guy did is, there are only 2 hard problems in distributed systems: guaranteed order of delivery, exactly once delivery, and guaranteed order of delivery, and then again, exactly once delivery, because in distributed systems, you cannot really guarantee the exactly once thing. So always think of failures. The distributed systems are bound to fail. Don't think in a way that you would always stop failure, but think in terms of how to recover faster from failures. I generally get asked this question, so how small is micro? Or how do you define nanoservice and these kinds of stuff? I have had written a service once that was merely 100 lines of code. So whoever is familiar with e-commerce works, for example, someone checked out on the website with a new address, and then it has to populate in their customer addresses as well when they go into my addresses part. So that was done asynchronously in the place where I used to work. So that particular cron, I think, ran every 5 minutes or something, and that did nothing. It just went to the sales order address tables where the new addresses were added, pulled it and put it into the customer addresses table, pretty easy stuff. So to do that, I think I used around 100 lines of code, and that thing was done. But it actually served a very good purpose that as soon as any of our customers check out with a new address, their address pops up in their My Accounts, My Address section within like 5 to 10 minutes. So think of small stuff, and yes, you can write a service which is 100 lines of code. Yep. At the end, it's always about the speed and agility of software delivery, because that's what all of us do. All of us are software developers or the DevOps people who helped software developers. It's always about releasing newer things, but in a controlled way where the blast radius is less. So that's why you always have to think about the speed and the agility of your software delivery. Breaking things in from monoliths to microservices is not easy. It always depends upon your team and how the organization wants to do it. But one thing that's for sure is you're going to increase the speed of things that reaches the market and helps the organization. So always be aware of that. You always be aware and focus on the speed and agility of software delivery. And that's about it. Questions are welcome. One more thing, the Iconic is hiring. As far as I remember, there is a post even for platforms engineer. There are some openings for full stack engineer as well. You can follow me at that handle. That's my first name, and you can find the slides in that particular URL. If you have questions, I still have the timer running, so yeah, go ahead. Any questions?
Anybody have any questions? I'll talk about how the agenda timing is slightly off in a minute, but we have some spare time.
Well, either I was super clear. Oh, nice.
Yep.
Your presentation was like mostly about decomposing the code base into lots of different services. Yep. Did you decompose the data layer as well? Do your microservices kind of all have their own individual data stores, or is there like, how is that managed?
Nice, nice. So, yeah, for us, basically, we didn't really decompose the data layer. I think that's always the hard part. I'll tell you that the microservices we did wasn't done by the book. It was more focused on the performance and let's get things rolling. As I said, it was a small team as well. That was one of the reasons. But the reason itself was let's get things rolling. The data layer, the ugly code died, but the database still lives. So I'd put it in that way. But the database was never the bottleneck. So in that sense, it was fine. But on the other side, whenever we did completely new stuff, it had its own database. Maybe it had only 6 tables or 10 tables, but at that point we already had, we didn't we didn't still added more tables to the existing databases. But yeah, the things that actually existed, maybe we didn't add more tables to it, but whenever, as per need be, we added some columns or did some changes, of course, yeah, we did that. So from the data layer point of view, yeah, it was not like one service talks to only one database, and then that gives information out to other services. It wasn't like that. Any more questions?
All right. There's a question over there.
You said you've only got 10 back-end engineers on the 150 services, but you must have other teams, UI and stuff like that. How do you test and make sure that you don't break something for the customer in the whole find, buy, sale experience when you're tweaking one of those 150 services?
Okay, as far as I understand the question, you're talking about how did we test stuff even in this. So yeah, those 150, it's a big number also because the backends were different than the front ends. They were completely two different services running, and that's why the number is high. In terms of testing, we always had a level of unit test for all the things that we wrote. We didn't really have a lot of integration or end-to-end testing, but I think we should have had that. I would really, at least here that I see at the Iconic, we have some integration level testings even for the front end, but from how we used to work, we generally had a good amount of unit tests that covered most of the scenarios, and that was how we basically did testing.
Did the lack of integration and end-to-end tests ever catch you out or often catch you out?
So sorry, I didn't get your question.
You said that you had a lack of integration and end-to-end tests. Did it catch you out very often?
No, generally not, because as the services were already small, you knew what the blast radius would be, but not even having integration tests that we didn't really suffer from that. One thing was we had an outsourced QA team for the mobile apps, and because mobile apps were the most chunk of the traffic, they would actually test things like really well, really thoroughly, and then they could catch stuff that even, let's say, some of the tests didn't catch. So because it was the same API used by the mobile apps, the web apps, and everything, and we had like a pretty strict way of getting things out for the mobile, that actually helped.
One question, what impact do you think this whole journey had on the structure of your team?
The structure of the team?
Yeah.
Okay, so basically, as I said, the number of backend engineers were around maximum of 10, maybe 12 at some times, but it was kind of fluctuating in the past 5-6 years. There were around 3-4 maximum front-end developers, and generally around maximum of 3 DevOps or SRE guys. So if I counted, probably like a team of 20 was altogether doing all of this while this 4 or 5 years. So the teams were really small. How did we do it, if I could add, is like, let's say if we did something like the production system or studio system, we would generally put like 2-3 people, let's say 2 backend engineers and 1 front-end engineer, and then they would be tasked to kind of do that part, that system. And later, after it's released, it would be like a common responsibility of the whole team members that are there to kind of maintain it. So that's how it was going on.
All right.
Yep.
Great. Thank you very much.
Thank you.
Join me in thanking Geshan. All right, so I'm just going to do a really quick changeover of some slides that I've refreshed. As I said, we are actually going to switch the afternoon tea and the intro to the open spaces. So we'll do the intro to the open spaces now, let everybody know what we're doing, and then we should be able to have a break for morning tea, which should be out at about 2:30. So let me just make sure I've got the right slide. Sure, that's close enough. I'll switch this over. So I will say as well, we couldn't fit all of those suggestions in. Obviously, there's only 12 sessions that we've got. So what we will do is, if you have something that you think is still really important to talk about, and there are other people who agree with you, then we'll give you the opportunity to do that in your own little groups anyway, if you wanted to. So this is how they've turned out so far. So they start at 3 p.m. We're going to do 45-minute sessions. If you've looked at the agenda on the website, you'll notice that they're not exactly lined up like this. And the one outside on the screens is also slightly wrong. Usually when timing things happen like that, I blame time zones, so I'm going to do that. We're all in the same one, but something went wrong. So at 3 p.m. after afternoon tea, in section number 1, which is just over there, to my left, to your right, we'll be talking about how to collaborate across distributed teams. Number 2, which is going to be right here, we'll use this side of the room, the right-hand side of the room. We're going to be talking about serverless and no-ops. Number 3 is over there, behind the curtain up on that raised section, is going to be how to train people in DevOps. Number 4, which will be outside near the sponsors, there's a section there where there's round chairs you might have seen during lunch. We're going to be talking about measuring DevOps and when the automation is done. So that is at 3 p.m. We'll run those discussions for about 45 minutes. play some music, get everybody up and moving. And then it'll be patterns versus freedom, leadership and management in the DevOps world, shifting testing left and test automation, and out there, hybrid cloud architecture and challenges faced and solutions. Then at 4:30, DevSecOps and how teams are shifting left on DevOps, running stateful DBs in the cloud, bringing the Newcastle tech community together, and then outside we'll be doing unconscious bias affecting orgs. Cool. Now, is there anybody who suggested something and can't see theirs up there, still really, really wants to talk about that session now? Put your hand up if that's you. Nobody. Cool. Awesome. Well, this will be the groups then. And again, whatever we talk about during those groups is the right thing to talk about. Whoever is there is the right person to be there. If you don't feel you're getting anything out of it or you're not contributing, feel free to use your 2 feet and walk to another section or go and sit somewhere else and wait that one out. It's no issue at all. But most of all, try to learn stuff, try to contribute, and hopefully over the sessions in the morning, right up until now, you've got a lot of stuff running through your brains that are going to contribute to these conversations as well. Now, that took 5 minutes, and morning tea's not out for another 25. So what we'll do now is I'm definitely not going to dance. We might break a little bit early then, and feel free to have some conversations, get the juices flowing for this kind of stuff, get ready for these conversations. Coffee is out there. Feel free to go for a little stretch and get ready for the open sessions later on today.
Sorry, can I add something? Yeah, I am open to questions even later, so if anyone has any more questions, yeah, I'm here. That's it. Yep. Awesome.
We will see you back at the sessions at 3 p.m. And I'll leave this up here so you can see it as well, if that's all right, James. Awesome. Thanks.